Hi, this is Maggie. In this video we're going to review the coordinate system used by Pygame and briefly overview how we simulate motion using the game loop. This image from the text shows the coordinates of a 480 by 480 Pygame window. The left top coordinate is 0, 0. This means the top of the screen is y coordinate 0 and the left of the screen is x coordinate 0. The y coordinates increase as we move down until we reach the bottom of the window at coordinate y equals 480, the height of the window. Similarly, the x coordinates increase as we move right until we reach the right of the screen at coordinate x equals 480, the width of the window. When we copy or blit an image to the screen at a particular coordinate, that coordinate specifies the upper left coordinate of the image. The image will therefore appear below and to the right of that coordinate. Here I have the ball image from listing 9.1, and if I want to blit it to the upper left corner of the screen, I'll blit it to 0, 0. The ball image is 71 pixels wide and 71 pixels tall, so the bottom right of the ball image is at 71, 71. Suppose I blit to 480, 480. What will that look like? What do you predict based on what you know? So remembering that 480, 480 is the bottom right corner of the screen, and that when I blit, I'm specifying the upper left coordinate of the image. If you predicted that the ball will blit to a part of the screen surface that we can't see, you predicted correctly. It will be below and to the right of the visible screen. We can also blit so the image is only partly visible. Let's edit a generic Pygame program to illustrate. A template I created that creates a window, blits a black background, and runs an event loop. We'll edit it to blit the ball image to an XY coordinate. I'll rename it to blitting practice.py, and I'll load in the ball as a surface. So, for example, I could blit to -20, -20. For each set of coordinates, predict the result before I run the program. I'm going to set x to -20 and y to -20. And then I'll write some blitting code after we blit the background. Blit the ball surface to XY. So, remember, predict the result. So the result of -20, -20 is that we see the bottom right part of the ball in the upper left corner of the window. Now how about 440, 440? Kind of the opposite. We see the top left of the ball in the bottom right corner of the window. And let's do one more. We could do 440, 200. The y coordinate is within the window near the middle, but the x coordinate, as before, means that the left of the ball is visible, but the right is chopped off by the right edge of the screen. So now that we've reviewed coordinates, let's think about what motion looks like. If I want the ball to appear to move across the screen, which I can illustrate on figure 9.1 in Visio, like this. Then its x-coordinate is increasing as it moves to the right. To simulate that with a loop, I need to erase the ball from its old location, calculate a new location, and draw it to its new location each time through the loop. If I do that 30 times a second, which is how often we enter the game loop, then the ball will appear to move. The more I add to the x-coordinate each time through the loop, in other words, the bigger the jump from one location to the next, each time it's redrawn, the faster it will appear to move. Each iteration of the game loop, we are constructing the equivalent of a frame of a movie. We do that by blitting surfaces to the screen. The screen is our frame. We then flip to reveal our completed movie frame to the user. So let's look at how that's done. Each time through the loop, we want to construct our frame. To do that, we will blit our background image to erase everything that was there before, followed by our ball. We then flip to show the screen surface we just constructed. Okay, and when we run that, our ball doesn't move. Why? Well, it's like we're showing the same frame over and over. To move it, before we blit it, we should change the coordinates. Let's start the ball at the left side of the screen and move it right. So we'll start it at 0, 200. The 0, the x-coordinate, means we're starting at the left edge. And the 200, the y-coordinate, means we're not quite halfway down the screen. We set that before the game loop, when we initialize the ball's x and y coordinates. Down in the game loop, we're going to change x, but not y. This will leave the ball at y equals 200, but if we add a little bit to x each time through the loop, which means 30 times a second, it will appear to move right. Let's add x plus equals 5. Just before we blit the background. So if the ball is at x equals 0, it will be at x equals 5 when we blit the ball. The next time through the loop, x will be incremented to 10. Blitting the background will erase the ball drawn at x equals 5, and then we draw at x equals 10. Next time it will draw at x equals 15, then x equals 20, etc. Let's run the program and see. And you see the ball starts at the left of the screen and moves right. In fact, right off the screen. So we will need to think about what we want to do at the boundaries if that is not the desired effect. Behind the scenes, it's still adding 5 and blitting, but we can't see it because it's blitting further and further to the right. So that is an overview of the basics of the coordinate system and motion. To practice with this, enhance your own template to include moving an image across the screen. Play with the starting location and the increment. Once you are satisfied you know how that works, move an image down the screen. Then try moving left and moving up. Once you have all that working, you're ready to move on.